Hello everyone, welcome to 526. This is week 10. In the previous 9 weeks, we have learned how to find a certain column, how to use a filter, and how to join multiple tables. From now on, we're going to learn more advanced topic like aggregate functions. So in chapter 12, that is for simple totals. Aggregate functions will summarize the information of a particular column by one single number. In this simple total case, for example, count star will return the number of rows for the table. And because all columns have the same number of rows in the table, which will include rows with null values. So when we were using count star, it's going to return the total number of rows of the table. Count the column name will return the number of non-null value rows. And the count distinct column name will return the number of distinct values for the column name column. There are a few other numerical, or even you can apply that aggregate functions not only to numerical functions but also date and characters. Those are the max, mini, and the average. Sorry, there's a typo here. Should be AVG. It will return maximum, minimum, and average value of a particular column or expression. So I'm going to show some examples by using these aggregate functions, and those are the simple totals. Again, for aggregate functions, they will return just one row for each column. Let's, based on our example, use our old friends, the sales order example database. And let's base the first a few examples based on the vendors table. Let's refresh what is in the vendors table. In the vendors table, we have multiple columns like a vendor ID, etc., etc., and vendor web page, etc., etc. So we do have a lot of columns here. One of the questions people may ask, in the vendor table, how many rows? Okay, to answer that question, let's run this. Select count star from a table will return the number of rows for that particular table. In the vendor table, it returns 10. There's 10 rows. And as I mentioned, count star is going to return number of rows no matter whether the value is null or not. But if you are interested in a particular column, and you do not want to include those rows with only null values, you can use the count with the argument to be the column name. Let's look at it, how many non-null values for vendor web page column. You can see it is 6. Let's go back to the vendor table to see what happens. In the vendor table, it is a fairly small table. It's only 10 rows. But for the vendor web page column, and there are 4 rows are non-value. So using the count vendor web page column name here, it's going to count how many rows where they have null values. So all those null value rows will be excluded, and so there's only 6 rows left. And this is exactly what happens for this SQL. It's returned 6. Okay, and we can also add filters in this particular one. For example, we do have one column called vendor name. How about if I want to know the vendor name in Washington State? Then we can add in the where filter with the vendor state equal to WA and count how many rows for the vendor name column. And we can also use the as keywords to give a name for the result. Let's write. As you can see, now we have a column name for the count result. It's the number of vendors in Washington. And this is what we actually define was the name for that. So that's the as keywords as we have used in the past. And we do know there are only 3 vendors in Washington. We can actually look at the vendor table to confirm the result. So in the vendor names and this vendor state, WA, vendor state is WA, there's only 3 rows. So there are 3 vendors from Washington state. And I have used select count vendor name from vendors where vendor state equal to WA. So we can add filters to the condition to count not only how many null values for a column, but for some subset column. And those filter conditions is defined by where clause here. We can also include distinct keywords in count to find number of distinct values. So for example, in this particular vendors table, what we want to count now is how many distinct states. People may ask, how many states your vendors actually come from? So, which means we need to count the vendor state, but we only want the distinct numbers. Any of the duplications from the vendor state column will be removed. So let's see what will be the result. It returned 6. Okay, in the previous vendors table, the details, the vendor state, we have Washington, Missouri, New York, Arkansas, and there's a duplicate New York, duplicate Washington, and then California and Texas. Altogether, 6 distinct states. So we can use the distinct keyword before the column name to find the non-duplicate number of values in that column. And you can also add a where clause to add in more filters if you want. Okay, those are some of the descriptions of how to use count. Count star, count column name, count distinct column name, as well as adding in a where filter for a subset. Now let's check the 3 other simple total functions. Those are max, mini, and average. And in this particular example, we're going to use the order detail table. Let's look at it. What is inside the order detail table? In the order detail table, we have order number, product number, quote price, and quantity ordered. So there's only 4 columns, but many rows. And let's look at each column. What's their type? Order number is integer, product name integer, coded price is a decimal number, and coded quantity ordered is a small integer. So they're all numbers. How about somebody's asking, can you show me the total number of quantity ordered for product number 6? So we do have the product number, and there's a quantity ordered for different order number. And what we want to know is what is the total number of quantity ordered for product 6, and we use the product number here. So to do that, what we can do is select sum quantity ordered from the order detail table where product number is equal to 6, which means we're going to only use number of rows where the product number equal to 6 and sum all the quantity ordered. That is going to give us the total number of quantity ordered for product 6. We write and the total number of quantity is 642. And in the sum function, in addition to column names, we can have expressions. Expressions can be column name, numerical constant, plus minus, product, division, and all different kind of numerical operations. In this particular one, we want to know the total cost for order number 20. So in order number 20, there will be a few different kind of items, different products. For each different products, we have the quote price, we have the quantity ordered for that particular product. And what we're going to do is use the sum function to sum the product of quoted price and quantity ordered. This is going to give us the cost for a single item. We sum those up for all the rows where the order number equal to 20. It is going to give us the total cost for order 20. And the total cost for order 20 is this number. This is the sum of all the rows where the product of the quoted price and quantity ordered. So that's an example. You can use expressions within an aggregate function. This is the filter. And now let's look at what's the max, what's the mini, and the average price for all the product, across all the products, and across all orders. So basically for that particular query, we're going to look at it for all the rows within the price columns, and what is the maximum value, what is the minimum value, and what is the average of quoted price across all products and across all orders. Okay, so we run it. You can find out the maximum price is 1800, the minimum price is 4.84, and the mean price is 328.97, etc. So as you can see, we can use multiple aggregate functions in one select statement. And there are actually two constraints on using aggregate functions. The first one is you cannot embed one aggregate function inside another aggregate function. For example, this is wrong, like a sum, an average, quoted price, and this is actually wrong because it's not allowed to embed one aggregate function within another aggregate function. And the second constraint is cannot use subquery inside aggregate function. So for example, this is wrong. Sum select quote price from order detail. This is not valid because we cannot have subqueries within a aggregate function. Those are the only two constraints for the aggregate function. Okay. One of the important usage of aggregate function is to build filters in where clause by subqueries. And if you remember, we actually used some of the subqueries in some of the aggregate functions before. And now let's repeat and get more in detail for how to build subqueries by using an aggregate function. Okay, now we're going to use the product table. Let's look at it. What is the columns in the product table? In the product table, we have product name, product number, product name, product description, retail price, quantity on hand, and category ID. So let's look at sample of the data from the product table, and those are the first 10 rows. So you can see there's product number, product name, product description, retail price, quantity on hand, and category ID. So the below query actually is going to fan out the product name where its retail price is larger than the average retail price across all different products. Okay, in this particular one, in the where clause, the filter, what we want to know is, let me write it here, is find all the products that their retail price is higher than the average retail price across all products. Okay, so first of all, we need to find out what is the average retail price. And the average retail price is, we can actually obtain through this subquery. Select average retail price from product table. So this is the average retail price. So it is built in as a subquery. So the where filter is become retail price larger than this subquery. The subquery is going to return the average price, and by running the whole query, actually we found out all the product names that their retail price is higher than the average. In this particular one, there is actually 4 different products. The advantage of embed a subquery within the where condition is, if, for example, tomorrow you have a few new products added to your assortment, then you run this query again, it's going to give you the right result, because this the average retail price will be changed when you add in or remove products, but the subquery is embedded such that the average price every time you run the query is going to be updated automatically as well. Okay, that's all for the chapter of simple total. And here is the assignment. Read through chapter 12 of the textbook and do the following exercise based on the sales order database. There are 3 questions, and please note the bulk questions are not exactly the same from the textbook. So it is similar to the one from the textbook, but are different. Please make sure you read through the question and hand in the right result. Thanks. Bye.